Dear students, in this video lecture series, we are seeing the subject data structure. In that we have covered linear data structure. We have started from stag, then we have seen queue, and now recently we have completed linked list. And in previous video, we have seen nonlinear data structure tree. In that we have seen basic terminologies. Now basically this subject is a bit tough to understand. So how to learn these difficult subjects? I have a trick to learn these difficult subjects, and that trick is whenever you watch a video, then you go on repeat the words which that teacher is saying. In that way what will happen? You are going to repeat in your mind, and that will be captured in your mind, and it will be helpful for you to remain concentrated on the video. Once you are giving enough concentration, gradually you will see that earlier which was looking like a very difficult task, very difficult subject, now you will observe that these subjects are not that much difficult. The question is of only concentration. So to improve the concentration, just go on repeating my words in your mind, and also watch the video till the end so that you will understand the concept properly. So let us start types of trees. There will be a question in your exam like list type of trees. So the answer for that question is number one is general tree, for which we have seen the definition in earlier video lecture. Then binary tree, it will be having only max two childrens. Complete binary tree is there, one of the version of binary tree. Extended binary tree, binary search tree, these are different versions of binary tree. And lastly expression tree. So these are different types of trees. Let us see each of them one by one. So let us first see what is a general tree. A general tree is recursively defined as a set of zero items in a tree. A set of zero or more zero items in a tree is called as empty tree. And second definition, the second part of the definition is if T1, T2 up to Tn are n number of trees, for n is greater than 0 and R is an item called a node, then the set T containing R and the trees T1, T2, Tn is called a tree. Within T, R is called as the root of the T, and T1, T2, Tn are called as subtrees. Earlier I told you that this is going to be a bit tough. So to understand this properly, let us read it one more time. What it is saying, basically it is saying that there will be one root that we have seen earlier. Then it is saying that there will be combination of different trees, and these trees will be joint. So instead of using the combination word, it is using a mathematical term set. So basically it is saying that general tree is a set of different trees in which there will be one node called as root node. Now this is very easy to understand. General tree represents some kind of hierarchical data. Hierarchical data means I will draw a diagram. It will be like this. At top one thing will be there, and below it some more things will be added. This type of diagram is called as hierarchical diagram. Hierarchy you can also observe in college as principal, HODs, class teachers, then students. So there is a hierarchy. You can also pronounce it as hierarchy. A general tree may not necessarily have 0, 1 or 2 subtrees. There can be any number of subtrees, right? So in a general tree, the number of subtrees, that is the number of children per node for any node, is variable. For example, some nodes may have 1 or no subtrees, other may have 3 or 4 subtrees. Children of a node can be stored in a linked list with parent node storing the address of a leftmost child. See the diagram. If you see the diagram, then it will be easy for you to understand. This is the diagram of general tree. What it is saying that it is not compulsory that B node should have only 2 children. It can have 3 children. The only condition is that it cannot have a cycle. What is cycle? Or it should be disjoint. That is C and D cannot be joined. If C and D are joining, then it is forming a cycle ACD. Then this is not a tree, it is a graph. We will be seeing graph in few lectures or in another videos. So I hope you understand the concept of general tree. Now the questions which are asked in the exam are explain the binary tree, types of binary tree, algorithm on binary tree, binary tree, binary tree, binary tree. You can see that the majority of the question which were asked in the exam were on binary tree. It were not on general tree. General tree is only for the purpose of understanding that there will be a common thing that is called as root and another thing combination of trees, right? This much only, this much definition you have to just understand and remember. There will be no question on this topic. The question will be asked on binary tree only, right? Now what is binary tree? Let us see a finite set of items which is either empty or consist of single item called the root, and the two disjoint binary trees called left subtree and right subtree is called as a binary tree. What it is saying? A finite set of data items. It is not infinite, it is finite, which is either empty. It can also be empty or it can consist a single item, right? For example, this is a tree having only single item. This is a tree having only single item. This is also a binary tree according to definition. And this is the root of the tree. This is the root of the tree. And there is one more condition. Two disjoint binary trees. There should be no joining, right? For example, I will draw here. This is your root and two disjoint trees I will draw here like this. So if I make a join from B to C, then it will not be a tree, because according to definition it should be disjoint binary trees called as this is left subtree and this is right subtree. Or in a very easy term, I can say that binary tree is a special type of a tree in which every node or vertex has either no children, see here, B and C are not having any children, or one child or two children. So here A is having two children and B and C are not having single child. So this is a binary tree. I will draw one more diagram here. Is it a binary tree? Yes, this is also a binary tree because it has having only one child. The condition says that it cannot have three children. If any node is having more than two children, then it is not a binary tree. The condition for binary means two. Basically binary itself means two. So there can be only two children at max. So now the question arises, why a binary tree is important? A binary tree is important class of a tree data structure in which the node can have at most two children. Now it is important because there are many terminologies depending on the binary tree. Many technologies are working on binary tree. Child of a node in a binary tree on the left is called as left child. This we have already discussed. And child on the right of the binary tree is called as a right child. For example, this is a left subtree and this is a right subtree. Okay. For B, there is only left subtree. There is no right subtree because right subtree is empty here. For C, this is the left subtree and this is the right subtree. Because according to definition of a tree, it can have 0, 1 or 2 nodes, not more than 2 nodes. So this was about binary tree. Now how to create a binary tree? See, algorithm to create a binary tree. There are 3 steps. Step number 1, step number 2 and step number 3. Step number 1 says if the value of new element is less than the current element, then go to the step 2 or else step 3. If the current element does not have a left subtree, then make our new element the left subchild of the current element, else make the existing left child of as our current element and go to step number 1. This is a bit theoretical. Instead I will tell you a very basic idea about binary tree. In binary tree, you have to just read the elements. The element will be given to you and that element you have to just arrange in a sequence or order, and that order should be like this. Suppose you have given this, all these nodes are given to you. At that time what you will do? You will first randomly pick one node and it will arrange at the root, and then you will make left, then you will make right. So left right, in this way you will arrange all these nodes and your binary tree will be ready. Just there is one condition for binary search tree, and that condition we will discuss in binary search tree. Right now we are seeing binary tree, and in your exam no one will ask you about algorithm. Just they will ask you the definition of binary tree, and the definition of binary tree is very easy. Then we will see operations on binary tree. The operations that can be performed on binary tree are creation, traversal, deletion, insertion, merging, copy, and compare. What do you mean by creation? Means creating an empty binary tree. Traversal means to visit all the nodes in the binary tree. Deletion means to delete a node from non-empty binary tree. To insert a node into an existing binary tree is insertion. To merge two binary trees means merge operation. To copy a binary tree is a copy operation. And lastly, to compare two different binary trees means compare operation. Then types of binary tree. The very first type of binary tree is full binary tree. A binary tree is said to be full binary tree if each of its node has either two children or no child at all. That is called as full binary tree. Sometimes it is also called as complete binary tree. See the diagram. Now in this diagram, you will see that every child at every level will either have two children or no child. For example, B is having two children and C is also having two children, F and G. But D, E, F, G are not having a single child. Hence, it is called as a full binary tree. The number of nodes in a full binary tree of height h will be this much. See here. Now, what is the height of this tree? The height of this tree is 3, right? So, the height of the tree, if the height of the tree is 2, then the formula says that 2 to the power h plus 1, where h is the height of the tree. Suppose this is the tree given, which I am highlighting. For this tree, the height of the tree is 2. Hence, according to formula, 2 to the power 2 plus 1, that is, and minus 1, that is 2 to the power 3, that is 8. 8 minus 1 is 7. So, there can be maximum 7 number of nodes. If we count, then there will be 7 number of nodes. See here, this is node number 1, this is number 2, this is number 3, 4, 5, 6 and 7. So, according to this formula, in a full binary tree or in a complete binary tree of depth 3, there can be 2 to the power h plus 1 minus 1 number of nodes. Okay. Second type of binary tree is complete binary tree. A complete binary tree is defined as binary tree where all leaf nodes are on level 1, are on level n or n minus 1. The only difference between full binary tree and complete binary tree is that about level. Leaf nodes will be at level 1. Skewed binary tree. Skewed binary tree will have only one side of the tree. Either it will be going on the left side or on the right side. Right? See the diagram. It is a left skewed binary tree and on the right side it is a right skewed binary tree. Then strictly binary tree. If every non-terminal node in a binary tree consists of non-empty left subtree and right subtree, then such tree is called as strictly binary tree. Only in your exam there is binary tree. Other types of trees are only for your purpose of understanding. There will be no question on these types of binary trees. The only syllabus says that binary tree and binary search tree. Okay? Now coming to the main point, that is binary search tree. Now in binary search tree, all nodes in the left subtree have value less than the root and all nodes on the right subtree will have the value more than the root. That is called as binary search tree. The name of the tree is binary search tree. The name itself indicates that it will be using in searching some of the elements. Okay. Now see here. Now if you observe this tree, the first number is 39, second number is 27, which is less than 39, then 18 is less than 27, 9 is less than 18. So all the nodes on the left side will be less than the root. For 27, 39 is the root and all the elements on the right side will be greater than the root, 45, 54, 59 and 65. Right. Now suppose anyone asks you to please find 28 number. What you will do? You will go to the root, check whether it is 28 because the number you are searching is 28. Right. You will then check 28 is less than 39. So you will go on the left side. You will check 27. 27 is greater than 28. So you will go on right side. 29. You again compare 28 and 29. You find that 28 is less than 29. So you go to the left side. Now you compare these value 28 with this node and you say that the number is found. Now how many nodes are there in this tree? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 nodes are there. So but how many comparisons you require? Only 1, 2, 3 and 4. At fourth comparison you got the element. So when number of data is very large and you want to search very quickly, at that time binary search tree will be helpful. Binary search method which we have learned in chapter number 2 is different and binary search tree is different. Don't get confused. In exam many students get confused between binary search method and binary search tree. Please don't get confused. Binary search tree is different. ठीक है. ठीक है. In next lecture we will see in detail what are the questions they have asked in the exam and how to understand that topic and apply that concept in real life. ठीक है.